Welcome to the AP Bootcamp Scientific Writing Session, explaining what your findings mean. Our lesson overview includes learning why lab reports are important, learning the components of a lab report, and learning how a lab report is written. There are some materials that you will need for this session, and if you do not have them in front of you already, please go to our course page for the AP Bootcamp on Canvas and find the session that is titled Scientific Writing, explaining what your findings mean, and you will find the link for the exemplar lab and guided notes. You will also find the link for the slide deck that accompanies this video, and you will also find the link for this video itself. Thanks for joining us, and good luck for the rest of the AP Bootcamp. On how to write a lab report, and that's going to include why lab reports are important. It's going to include the components of a lab report, and it's going to include how a lab report is actually written. But before we can do that, we have to talk about what a lab report is. And a lab report, simply put, is a document that includes a description of what happened in an experiment, as well as the data analysis for that experiment. And both are very closely tied to a scientific concept that a scientist would want to know. Lab reports are often used to describe or define a problem or a topic that is being researched, and they are used to explain conclusions that are drawn in an experiment. And we're going to talk about that a little bit later in this video of what that actually looks like. Lab reports are usually published, and they're usually published in what we call scientific journals. And one of the reasons why they are published is so that scientists who might want to consider doing a similar scientific study, or they're looking to do a similar experiment, can go back and look at those lab reports and see what went on in them, and they can design an experiment from there. And some of those experiments may be under different conditions, but it may be considering some of the same factors that are found in previous lab reports. So lab reports are really important in terms of publication. Lab reports are typically help scientists develop skills in inquiry, as well as in scientific methods and scientific communication. And this is going to be really important for you because those are the skills that we as instructors are looking to develop in you as students. We're looking to see you have a piqued interest in scientific concepts. We're looking to see you develop your own experimental designs, and we're looking for you to learn how to communicate what you've actually done in a lab or in a lab experiment. So why are lab reports important to the scientific community? Why do we even have them in the first place? And so basically, lab reports are not only for scientists to figure out what was done before so they can design an experiment, but it's also used to improve on experiments and also prove or give validity to results to experiments that have taken place before. So, for example, if you are trying to figure out if aspirin really does work well or help heart patients, you might want to look at the results from experiments before, and then to improve on what aspirin can do for heart patients, you will conduct an experiment to validate those results, as well as improve maybe some of the medicines that are used to help those who have heart conditions. So, what are the contents of a lab report, or what are the components of a lab report? And you should find a title page, you should find an abstract, introduction, methods and materials, data, analysis, and a conclusion in a lab report. We're going to start with the title page, and the title page is usually very straightforward. There's not a lot of fluff. You're looking for 10 or less words in the title page, and usually it's going to include something called qualitative or quantitative. And qualitative is anything that is collected in words, so anything that is written or said, and quantitative is going to be anything in your lab report that has to do with numbers. One of the things that has to do with your title page is that when you are creating it or creating the title, you want to make sure that you use something that is from the actual lab or experiment. So you should not be using a lab number or a lab name that is on the printed paper that your teacher has given you. You should be developing your own lab title from the work that you have done. The title page, on the title page, you should find the actual title of the lab. You should find the author's name, which would be you, and then you're going to have a list of your lab partners on the title page, along with the date and the abstract. And we'll talk about what the abstract is in a few moments. So you should be able to see on your exemplar lab report guided note sheet the format for the title page. And you see that we have a lab title, which is the effects of positive and negative chemotaxis on pill bug behavior. You see myself, Miss Piper, as the author of the lab report, and then you also see the instructor for our lab, and that is the person, Miss Torre, who is over all of AP for Guilford County. You see the date is on here, and you see my lab partners, which are the other two instructors for this AP Science Boot Camp, Miss Allison and Miss Garrison. And then you also see the sample abstract that is related to the pill bug lab and the overview of the actual experiment. So let's talk about the abstract that is found on the title page of a lab report. An abstract is a summary or an overview of a lab experiment and report, and scientists use it to determine whether or not they want to continue reading the report or to decide whether or not they want to conduct a similar study. Just when you're writing an abstract, you want to be mindful that it is not a restatement of the conclusion, but however, you will find that there will be an overall conclusion that was drawn that is included in the abstract. The abstract, though it shows up or usually is placed at the beginning of your lab report, is usually written last or created last. So it's created after the experiment and the report has been completed. So after the abstract, you should find the introduction within the lab report. And an introduction is a summary of the purpose of the lab. And the introduction usually includes key terms that are significant to the experiment or the lab. And those words are usually underlined, just like you see in the sample introduction on your exemplar lab report and guided notes. You see we've underlined pill bug, choice chamber, chemotactic. Those words are significant to what actually happened in the lab experiment. So that's what you want to underline in the introduction. Once you have done that in the introduction, you don't need to do that anywhere else. So you only need to underline your key terms once in the introduction. So following the introduction of the lab report, you're going to find the hypothesis, and the hypothesis is based on previous research. It's a prediction of the outcomes of what would happen in a lab experiment under certain conditions. And it is not an educated guess. It is a prediction based on what has been seen in past experiments. And you can see in our sample hypothesis for the pill bug lab that there's some background information on how pill bugs have a positive chemotactic response to moisture. And so because of that, we're going to see that in a choice chamber that pill bugs are going to move towards the wet side of the chamber. And so we can make that prediction or formulate that hypothesis based upon past research or what has been seen with pill bugs in the past or previously. So hypothesis is a prediction based on information that has been proven before. So once you formulated your hypothesis, you can move forward with your experimental design. And your experimental design usually includes the methods and materials for your lab experiment. And it usually includes a figure that describes your methods as well as the specific details of what you have done in the experiment. The figure that describes your method in picture form is usually called an apparatus, and it is also usually labeled in the lab report. You want to be specific about your methods and materials for your experimental design or for your procedure, but you also want to go straight to the point. There is no fluff. This is not a time to get poetic and get practice imagery. You've got to go straight forward when writing your experimental design. And so you can see in your exemplar lab report and guided notes a sample of the apparatus. You see where there is the actual tools that are being used, the choice chamber. You see that the choice chamber is labeled with an A side, a B side. So you also see that the A side is dry, the B side is wet or moist. You see that there's a control, and the control is the part of the experiment that you do nothing to. So both sides of the chamber in this case are going to be dry. You see that there's the experimental a chamber or group, and you see that there's an A side and a B side, and the A side is dry while the B side is wet. You also see that there's numbers. You see the number of pill bugs, which is 30, that are placed into each chamber. You see that there's a pill bug and it's being labeled and is specific about the scientific name for the pill bug. And you have to remember that the apparatus is a figure, so you're going to label it figure 1. And so also in the materials and the methods and materials, you're going to find the procedure, and the procedure is basically what you did in the experiment and should be written in past tense or as though it has happened already. Again, you want to be specific about numbers, how long, how much, how many, and you want to make sure that we're not using bullet points. It's going to be really important that you remember not to use bullet points throughout your lab report, because on your AP exam, you will have to write your lab report if given in a free response. You're going to have to write it in paragraph form. There's no need to have an introduction or a conclusion sentence in your procedure. It doesn't add anything for points or anything like that on your exam. So nor will we do that as instructors with you in class throughout the year. And you don't need any extra information. You just need the information that actually happened in the lab. So you can see in your exemplar lab report the actual sample procedure. You see where we're very specific about numbers. You see 5 minutes. You also see the specifics of the control. You see the specifics of the experimental group, and you see what we actually did, what we recorded. So it's really important that you are mindful of that. Once you have created your experimental design and conducted your experiment, you're going to be recording what's called data. And data is or includes the observations and results from the lab experiment, and you're going to record what is actually seen happening in the lab. The data also includes your observations in a chart form. So you're going to actually create a chart, and usually that chart is labeled as a figure. And so you can see in the exemplar lab report and guided notes the sample data in figure 2, where the information or the data that was collected related to the pill bugs in terms of their behavior, whether they were moving around randomly in the control chamber, in the dry, both areas being dry, whether you saw not any of them moved at all, or whether you saw that some were moving from side A to side B, side A being dry, side B being wet, and that the pill bugs were moving towards a more moist area. So you can see actually the numbers and the specificity around numbers. As I mentioned earlier, you see that there are 12 pill bugs in side A in the control, and 18 in the side B of the control. And you can see the difference in the experimental group as well in that data. Once you have recorded and collected your data, you're going to do something called analysis. And analysis is an interpretation of your data. It's basically what in the world is the data telling you. And so that analysis can be written or be in Word form or in graph form, and most scientists lean towards graphs. And so when we start looking at graphs, you got to consider that there is an X and a Y variable with graphs. And if the X and Y variables are both numbers, then you're going to draw something called a scatter plot graph. And we'll talk a little more about that as you move about in AP Science, but you need to be mindful of that. But if the variable has numbers and then another variable has alphabets or letters, you're going to use what's called a bar graph. And how do you know what goes where in a graph? You have to consider the two major variables in an experimental design, and that's going to be the independent variable, which is the part you manipulate, that you control, that actually can have an effect or cause something to happen, and that is going to be on the x-axis, while the dependent variable is going to be on the y-axis, and that is the part that is being affected or actually changed as a result of what's been done by the independent variable. So if there are any other mathematical problems that you've worked out, any statistical problems that you've worked out, you want to make sure that you also include your math work in this section of your lab report. And so both are going to be considered figures, both the graph and both the mathematical work that you have done in your experiment will be labeled as a figure. And so you can see the example here. You can also see the sample analysis graph, where you see the numbered variables on the y-axis, while you see the alphabets or the letters on the x-axis. So you know that the dependent variable are going to have to do with the number of pill bugs, while the independent variable is going going to have to do with the choice chambers. And you can also see that it is labeled as figure 3, and that it is an actual bar graph because there are letters and numbers. You can also see in your guided notes the actual math that was done for this lab for the pill bugs, and this is called chi-square. You'll learn more about that in your AP Science courses, and specifically you will learn it in AP Biology, and if you take AP Statistics, you'll learn it there as well. The last section of your lab is the conclusion, and conclusions are written to explain the correlation between the data, the analysis, and the hypothesis. The conclusion also includes or states the evidence for the claim made in the hypothesis, and you're going to see an overview of the data and the analysis in the conclusion. Simply put, you're looking to see if the analysis and the data actually support the prediction of the results before the actual experiment was conducted. You're going to be specific in your conclusion, and you're going to include references to the figures that are throughout the report so that the scientists who are reading your report can follow along and understand what you're talking about. You're going to also identify the control and experimental groups in your conclusion, and you're going to also state what you learn and cite the evidence for what you've actually learned from the experiment. And you can find in your sample conclusion that all of that is taking place. You see the control group being mentioned. You see the experimental group being mentioned and what has happened with it. You're also seeing the reference to those scientific terms that were mentioned earlier in the lab report. And you're also seeing that there is a correlation between the data and the analysis and the actual prediction made in the hypothesis. This concludes our lesson on scientific writing, explaining what your findings mean.